To get more video, please subscribe the channel. Student, today we discuss about the next questions of the practice set 5.1 of the chapter Coordinate Geometry, Mathematics Part 2, 10th standard. Now the question number 5 is, show that points P2 minus 2, Q7 3 are 11 minus 1 and S6 minus 6 are the vertices of parallelogram. Student, for this we have to show here, this is an parallelogram, means that the opposite sides are congruent or equal to each other. Then this is a parallelogram also. So we have to show here its opposite sides are equal. For this we use distance formula. So its solution is, I will take a distance formula. So write here by using distance formula. First I will write the distance of any two point here. Suppose that distance of PQ is equals to, the formula is that here is x2 minus x1 bracket square plus y2 minus y1 bracket square. By using this formula, we have to find out distance of all these segments here of this quadrilateral PQRS. So that first PQ is equals to, here in this formula we have to substitute the value of PQ. Let P is x1 y1, this is x2 y2, Q is x2 y2. Then by using h2 minus x1, means that 7 minus 2 bracket square plus y2 is 3 minus 2 bracket square. Then student, the subtraction is 5 square plus 3 plus minus plus 2 bracket square. Means that root of here 5 square is 25 plus this is also 5 square. Means that here is root of how much? 25 plus 25. Means here is root of 50. Again we factorize it. So that 25 into 2 means therefore this value becomes 5 root 2. This is equation number first. This is the distance of the PQ. Then we have to find out distance of QR. I have to directly use this formula here. By substituting value this of the QR in this formula, we get that this is x1, let this is x1 y1, this is x2 y1. Then h2 is 11 minus 7 bracket square plus y2 is minus 1 minus 3 bracket square. Student, this is subtraction is how much? 4 square plus minus 4 square. Then this value becomes 16 plus 16 is equals to root of 32. Then we factorize it. Again 16 into 2. So that QR is equals to 4 root 2. Suppose that this is equation second. Then we have to find out RS. For this RS, again we have to use the distance formula by directly substituting the value of x2, x1, y2, y1. We get here, let this one is x1, y1, this is x2, y2. Then 6 minus 11 bracket square plus minus 6 minus 1 bracket square. Student, the subtraction is, this one becomes minus 5 bracket square plus this one is minus 6 plus 1 bracket square. Then student, we write here minus 5 bracket square plus this again minus 5 bracket square. The square of this one is 25 plus 25. It again becomes how much? 50. Then 50 means we have to again factorize it, 25 into 2 so that RS is equals to how much? 5 root 2. This is suppose equation 3. Then we have to find out the value of PS. Again by using this distance formula, PS is equals to in root of. Now let consider as x1 y1 x2 y2. Then this value becomes 6 minus 2 bracket square plus this becomes minus 6 minus 2 bracket square. Now this is 4 square plus minus 6 plus 2 bracket square. Then it becomes again 4 square plus minus 4 square is equals to 16 plus 16 is equals to root of 32 plus, sorry, is equals to, I have to again factorize it, 16 into 2. Therefore, PS is equals to 4 root 2. Suppose this is equation number 4. Student, observe equation first, second, third and fourth. The observation is that from first and third, PQ is equals to RS. So, I have to write here PQ is equals to RS. Reason, from equation first and third. And QR is equals to PS. Both are 4 root 2, 4 root 2. From equation second and fourth. Mean that, student, the opposite sides of this quadrilateral PQRS are equal. That is, they are congruent. Therefore, they are equal means they are congruent also. PQ is congruent with RS and QR is also congruent with PS. Therefore, the opposite sides of quadrilateral PQRS are congruent. Therefore, quadrilateral PQRS is parallel. Now, student, then we write the answer in full sentence. The answer is, here is, show that these vertices are the vertices of parallelogram. So, I have to write here, therefore, P in bracket 2 minus 2, Q in bracket 7 3, R in bracket 11 minus 1 and S in bracket 6 minus 6 are the vertices of parallelogram. Can you understand this? Okay, we take the next example. Question number 6. Show that the points A minus 4 minus 7, B minus 1 2, C 8 5 and D 5 and minus 4 are the vertices of rhombus ABC. Student, so same as earlier example. Now all of you know that the property of rhombus, all sides are equal. Mean that by using distance formula, we have to show that all these sides of this quadrilateral ABCD are equal. Then it is a rhombus. So solution. First, I have to write here by using distance formula. By using distance formula. This formula is distance of any segment. I have taken here AB. Here formula is x2 minus x1 bracket square plus y2 minus y1 bracket square. Student, first I have to find out the distance of AB by using this formula. A having quantities minus 4, minus 7 and B having quantities minus 1 and 2. Student, this one is, suppose x1, y1, this is x2, y. Then I have to write here minus 1 minus 4 bracket square plus y2 is 2 minus 7 bracket square. Then this value becomes minus 1 plus 4 bracket square plus 2 minus plus 7 bracket square. Then this value becomes, this is 3 square plus this is 9 square. 3 square is 9, 9 square is how much? 81. It becomes 90. It becomes 90. Then I have to again factorize it. This one becomes 9 into 10. We can find out the square root of this 9. Then we have to write here AB is equals to 3 root of 10. Suppose that this is our equation number first. Then we have to find out the segment BC. AB, then BC. Look carefully. Let this is x1, y1, this is x2, y2. Then x2 minus x1 bracket square plus y2 is 5 minus 2 bracket square. This value becomes 8 minus plus 1 bracket square plus this one is 3 square. This is 9 square plus 3 square. Means that again it is 81 plus 9 is equals to root of 90. Again we have to factorize this root. 90 is 9 into 10. Therefore BC is equals to 3 root of 10. This is suppose equation number 2. Then we have to find out here CD. Again we use this distance formula. Here is x1 y1, this is x2 y2. Then by using 5 minus 8 bracket square plus minus 4 minus 5 bracket square. Student, look carefully. The square of the subtraction is minus 3 bracket square plus here is minus 9 bracket square. Now student, this is 9 plus 81. It becomes again 90. We have to factorize it. 9 tens are 90. Therefore, length of CD or distance of CD is equals to 3 root 10. This is equation suppose that third. Then we find out AD. Let this one x1 y1, this is x2 y2. Then AD is equals to. Again we use this formula. Here is x2 is 5 minus minus 4 bracket square plus y2 is minus 4 minus minus 7 bracket square. This becomes 5 plus 4 bracket square plus this is minus 4 minus minus plus 7 bracket square. This is 9 square plus minus 4 plus 7 becomes how much? 3. Then student, this again 81 plus 9 is equals to 90. We can factorize it. 9 tens are. Means that AD is equals to 3 root 10. Equation number 4. Now when we observe equation first, second, third and fourth. AD is 3 root 10, BC is 3 root 10, CD is also 3 root 10 and AD is also 3 root 10. Therefore I will write it from equation first, second, third and fourth. AB is equals to BC is equals to CD is equals to 8. Therefore quadrilateral ABCD is rhombus. Now then we have to show that these all points are vertices. So I have to write the answer in full sentence. Answer. Therefore A having coordinate is minus 4 minus 7, B having coordinate is minus 1 2, C having coordinate is 8 and 5 and D having coordinate is 5 and minus 4 are the vertices of rhombus ABC. Okay, we take the next question. Next question, question number 7. Find x if distance between L, x, 7 and M having coordinate is 1 and 15 is 10. Now student, again we use here distance formula, so its solution is, I have to write this formula by using distance formula. Here is distance of LM we have to take here. This one is x2 minus x1 bracket square plus y2 minus y1 bracket square. Now here is L having coordinate is given here x and 7 and M having coordinate is given 1 and 15 and distance of LM is how much? 10. Now student, we substitute this value here. Let this one is the x1 y1, this one is the x2 y2. Substituting direct this, we get here LM is 10 is equals to, in this root of x2 is 1 minus x bracket square plus y2 is 15 minus 7 bracket square. Student, this one becomes 10 is equals to in root of 1 minus x bracket square plus this one means when we subtract this 15 minus 7, then it becomes 8 square. Then again I will take here, this is 1 minus x bracket square plus 64. For the removing this root sign, I have to squaring both sides we get. So write here squaring both sides we get. When we have to squaring both sides, then 10 square is 100. Then this sign get removed here. So that 1 minus x bracket square plus how much? 64. Transpose this 64 to this side. I have to write as in it. 100 minus 64 is equals to 1 minus x bracket square. Student, when we subtract here, this subtraction becomes how much? 36 is equals to 1 minus x bracket square. Then again taking square root of both sides. We get here the square root of 36 is plus minus 6 is equals to 1 minus x. That is, I have to write here 1 minus x is equals to plus minus 6. Mean that 1 minus x is equals to plus 6 or 1 minus x is equals to minus 6. Student, I have transferred this 6 to this side and minus x to this side. We get that 1 minus 6 is equals to plus x, or here also 1 plus 6 is equals to minus x, transpose and converted as plus x. Then the subtraction is minus 5 is equals to x, or here is 7 is equals to x. Therefore x is equals to minus 5 or x is equals to 7. Now the question is asked that find x, so that answer in full sentence, answer. Therefore the value of x is x is equals to minus 5 and x is equals to how much? 7. Okay, we take the next question. Question number 8. Show that the point A 1 and 2, B 1 and 6, C 1 plus 2 root 3 and 4 are vertices of an equilateral triangle. Now its solution is. Student, here is A having coordinates 1 and 2, B having coordinates 1 and 6 and C having coordinates 1 plus 2 root 3 plus 4 here. Student, we have to show here this A, B, C are the vertices of equilateral triangle, means we have to show here all distance of AB, BC and AC. AB, BC and AC are equal here. So we use here by using distance formula. So write here by using distance formula. Now the distance formula is, I have taken for any distance here, AB is equals to x2 minus x1 bracket square plus y2 minus y1 bracket square. Now student, I have to take here for this AB, let x1 y1, this one is x2 y2, we get here 1 minus 1 bracket square plus 6 minus 2 bracket square. Now 1 minus 1 is 0 square is 0 plus this one is 4 square. Then it becomes here 0 plus 16. 0 plus 16. Therefore root of 16. Therefore AB is equals to 4. This is equation number first. Then BC. Again we use this formula, distance formula. Now here for this BC, x1, y1, this is x2, y2. So first I have to write here x2 minus x1. Mean that 1 plus 2 root 3 minus 1 bracket square plus here is 4 minus 6 bracket square. Now student, look carefully. This one is 1 minus and this plus get cancelled, means here is 2 root 3 bracket square plus here is minus 2 bracket square. Then square of this is 4 into 3. Root 3 square is 3. Then this is plus 4. Mean that student, look carefully, 12 plus 4 is equals to how much? 16. Therefore BC is equals to Suppose the is the equation number 2. Then I have to find out the value of AC. AC is equals to, again we use distance formula. For this A is x1 y1 and this is x2 y2. So again I have to write here 1 plus 2 root 3 minus x1 is 1 bracket square plus here is 4 minus 2 bracket square. When we subtract it, the subtraction 1 get cancelled, means that 2 root 3 bracket square plus again 2 square. Then this square is 4 into 3 plus 4, means that the square is, the product is 12 plus 4 is equals to root of 16. Therefore AC is equals to 4. Suppose that this is equation number 3rd. Then student, from equation 1st, 2nd and 3rd, from equation 1st, 2nd and 3rd, we have, observe carefully, AB is equal to 4, BC is equal to 4 and AC is equals to also 4. Therefore AB is equals to BC is equals to AC. Therefore triangle ABC is equilateral triangle. And we have to show that these are the vertices of the equilateral triangle. So write the answer in full sentence. Answer. Therefore A having coordinates 1 and 2